Hello everyone, I'm Paul and today we're solving problem 1695, maximum erasure value. This one is medium and here we show you my intuition, approach and efficient solution. We are given an array of positive integers nums, such as this one, and here we need to erase a subarray containing unique elements. And by erasing this array, we earn a score. And the score we get is equal to the sum of the elements in the subarray. So for example, if we decide to remove this subarray, the score in this case is 6. And we can remove this array because it includes unique elements. For example, if we take this array, here we have 2 4s, so we can't erase this array. So our job is here. We need to return the maximum score we can get by erasing exactly one subarray. And the solution here is to erase this subarray. 2 plus 4 is 6, plus 5 is 11, plus 6 is 17. So we return 17. Now, in case you don't know what a subarray is, it's a contiguous subsequence of an array. So for example, these 3 elements are a subarray. This is a subarray, but we can't take these 2 and this. This is not a subarray. So we have an array and we need to remove some contiguous subsequence here. And when I see something like this, I think about sliding window. So now I will show you how to implement this. We are iterating this with 2 pointers, left and right. They are both initially here at index 0. And we will also have a map. The result will be 0 initially, and we will have a variable total, which will be 0 initially. So first we start here. And first we are adding this to total. So now our current sum is 4. And we are adding this to our frequency map. So now here we have a 4 with a count of 1. And the result will be the maximum among the result and total. So in this case 4 is greater than 0, so the result right now is 4. Now the right pointer is here and we follow the same process. We add 2 to total, so this is now 6, and we add this to our frequency map. So now here we have a 2 with a count of 1. And given that 6 is greater than 4, the result is now 6. Now the right pointer is here, and here is the key for this problem. This is the tricky part. First we add 4 to total, so this is now 10. And then we add this to our frequency map. So now here we have a count of 2, meaning we have seen the number 4 2 times. So we no longer have unique elements. So in this case, we want to update the left pointer. And before doing this, we need to subtract this from the map and this from total. So we subtract 1 4 from the map, so this is now 1. And we subtract 4 from total, so this is now 6 again. And now we can update the left pointer. Now the left pointer is here and every count in the map is 1, meaning every element is unique up to this moment. So now we check what is the maximum between 6 and 6, so we keep 6 in the result and we update the right pointer. Next, right is here, so we follow the same process. First we add 5 to total, so this is now 11. Next we add 5 to the map, so now we have a 5 with a count of 1. And given that we have all ones here, this means we only have unique elements, and we can compare which is the larger number between 11 and 6, and it's 11, so now the result is 11. And we update right again. Now right is here and we follow the exact same process. We add 6 to total, this is 17. And next we are adding this to the map, so we add 6 as a key with a count of 1. And given that we only have unique values, we can update the result with the maximum among 11 and 17, so the result is now 17. Finally, we update right, we reach the end, so we end this loop here. and we return the result, which is 17. So here you can see the final window that we are erasing. It goes from the left pointer to the right pointer, and the sum for this is 17. So this is the entire approach. Time and space complexity for this will be big O of n. Now let's go with the code and hopefully you will get the idea. First we say n is length of nums. We have to create an empty map, so we will use default dictionary here, default dictionary, and we will set a default value of 0 for every key. That's why we use the word int here. Initially total is 0 and the result is 0. And finally we want to return this result, and here in between we say left is 0, and we will iterate every value in n. So for right in range n, first we need to add the current value to the map. So map at nums right plus equal 1. Now we want to add the corresponding value to total, so total plus equal nums right. And now we want to check if we need to update the left pointer, so we can say while left is more than right and map nums right is equal to 2, meaning this value is no longer unique. We need to subtract 1 from map nums l, so this is minus equal 1. We need to subtract the corresponding value from total, so total minus equal nums l. Now we can update the left pointer, so l plus equal 1. And after all of this, each time we want to update the result, so result is the maximum among the result and total. And finally we return result. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.